So if you go back
in the previous slide.
Right, so if you go back here, we put this, so this is different experimental data than we showed later. Basically, this is a very controlled reactor that we have a really good model for. This data, we don't really have so they did this in what's called a temperature programmed desorption experiment. Without getting into too many details, it's really hard to model that with equations that people know. So we tried it, and to answer your question, I would say about a factor of 2, but the trends are identical, which is what matters, or is what we're looking for when we do this type of an exercise. So basically, we can in fact predict which material will be more active, but not quantitatively. To answer your question. Yeah. So just some conclusions. Started off by talking about biomass as a resource, and biomass gives us a domestic alternative for energy, which can improve our energy security, economic and environmental benefits. Talked about biomass reforming to syngas. So one thing to take away from this presentation is the usefulness of synthesis gas. If we can create that, we can create all kinds of useful things, chemicals, fuels, and if we can create synthesis gas from biomass, we can alleviate some of the burden from fossil fuels. Basically, if you remember that pie chart, we're expanding the slice of pie for renewable energy. Metal catalysts can increase the reaction rates and product selectivity of biomass reforming. If you remember from that one equation I showed, basically these metal catalysts lower the threshold energy, or the activation energy for each reaction, which increase the rate. And then, I showed the example from my work where computational chemistry can be used as a tool in parallel with experiments to better target what experiments we want to do to find active and selective catalysts. And then finally, just a note here, these problems that we're working on, there's always going to be more problems, and there's really not enough people working on them. So, there's great opportunities in engineering and science in general. So I'd encourage you to go into that field if you're interested in it, definitely. Okay, does anyone have any questions? Before I'm done, I have to acknowledge the Energy Frontier Research Center, which is similar to the CCEI, for making this possible. And thank you for your attention and your attendance. So, yeah, any questions?
Hey guys, thank you very much. That was excellent. Now I know that for a lot of you, that was science above and beyond what you've learned yet. If you're in the 9th or 10th grade right now, particularly 9th graders, this is an exposure.
I just need to show of hands for
9th graders. Okay. If you're in a 10th grader, you're starting to learn about biomass, right? You're starting to learn about the biology of this. You got to that. You guys that are juniors and taking honors in Cambridge chemistry, you touched on some stuff that you're going to be learning about. Some of the reactions that you put up there. You'll be able to read those before this year is out. You'll be able to understand what the molecules he was showing, how he wrote them, what that means. You guys that are seniors in the AP class, we're going to be getting into reaction rates. You're going to be fairly knowledgeable on that. The point is as you move through your high school career here, you're going to get more and more exposed to this, and it's going to start making more and more sense. But it never really ends. Some of the stuff that he's talking about right now, I guarantee you, if you'd have swapped seats 7 years ago, right?
Yeah.
You knew none of this. It's a growth experience, all right? And you guys have an advantage now of being exposed to it a little bit at a time. And there's no testing going on here. So you're moving up. The other thing is just the enormous number of disciplines that I heard you mention on the way through. You're talking about the organic chemistry involved in syngas production, and then once you have the syngas, what do you do with it? There's the economics of the whole thing. Where do you spend the money? Once you have the syngas, do I make this, do I make that? Where's the money? There's the environmental aspects. If you're really involved in environmentalism, you want to be active about it. Is it better to use biomass to create more, what essentially are fuels and not a whole lot different than gasoline, or should we be diverting it to hydrogen for fuel cells? You have the computer programs.
Yeah.
Somebody has to be developing those computer programs,
Science.
right? All that computer science, better, faster computers, the hardware involved in that. We said it takes hours. I mean, hours. I was surprised at that. I would have thought seconds, right? But these are complex computations.
Yeah, and you're running that on.
I'm running these on supercomputers.
Yes.
think.
So
Yeah.
there's a lot there. The physics involved in this, the opportunities are just enormous out there. And so I would encourage you all to continue coming and get that free pizza.
Yeah, we'll have pizza in a few minutes, by the way, so there'll be ample time to think about any questions you have. I mean, like really anything from this research to college to
Ask me how I got into this field, anything like that.
You know, Mike, that's a question that I'd like to discuss with Mark. Anytime we have these meetings, it would be nice if the speaker provided a little update about their resume, how they started in high school to move to chem engineering. That would help the kids also. You know.
Did you go to high school?
Yes. So I graduated in 2003 from Birmingham Groves High School, which is a high school in Detroit, Michigan. Then I attended University of Michigan for 4 years. So graduated in 2007, and then that's when I came to Delaware.
Which department, Mike?
Chemical engineering at University of Michigan, yes. And
It's also a top program.
yeah, so I actually some of the professors I had at University of Michigan got their PhDs here at Delaware and kind of encouraged me to come here. So it's been great.
So you are here for master's or PhD?
PhD. So this is my 4th year here in the PhD program. So winding down a little bit, but plenty of work to do.
And what are your plans after you graduate?
That's a good question. I don't know yet.
You're thinking academia, industry.
That's a pretty good lesson, I thought. So
Yeah, I don't. Academia is exciting. It would be nice to do my own research in academia, but at the same time, it's it's a little bit more abstract. Yeah, even going into industry is much faster paced.
And a little more tempting.
Yeah, a little tempting as well. But in academia, you have freedom of thought and freedom of research. So there's benefits to both sides.
I think a student had a question.
Oh yes.
You talked about a lot of the aspects of it, but like, do you guys do anything with the politics of the whole thing?
No, well, so generally, I would say the engineering field stays out of the politics. That's a general comment. So myself, no. However, I mean, we have, in my research group, we do have people that are active, active in the politics behind. There's
Engineers with help work.
right. There's next month there's a symposium at Delaware, renewable energy symposium, and these are my coworkers, my colleagues who are putting this on, talking about the benefits of clean energy and things like that. So yeah, I mean, well, professionally, I would say, people in my field aren't necessarily into the politics. If you have a passion for that sort of thing, absolutely, people get into that all the time.
Personal versus professional. Right?
Yes.
You have people who don't get involved professionally, don't involve themselves in politics at all. You have a research focus that is utterly fascinating to them. They move on and dig deeper and deeper into it. And then, oh, by the way, I vote every election, and I have my own politics also. And a lot of times that informs your research, and other times it's the other way around. Your research informs your politics.
Yeah.
It should be both ways. Your research should certainly inform your politics. The number of times that people will tell you they have a political stand based on a fact that is simply not true. So,
Yeah, I mean,
that's a personal bias, by the way. I believe scientists in a lot of the political arenas are better informed.